The diagram below shows two parallel rays, A and B, of red and violet colors. You can see one is a red color and is a violet color, respectively incident from air on glass boundary. This is the glass boundary. So basically it is like a glass here. Fine. So complete the diagram, show the refracted rays from them in the glass. So we know that wavelength of red is bigger than that of violet, right? Than of that of violet here, right? Some problem here, just 1 second. So red has got bigger wavelength here, okay, than violet. So which means the red has got bigger wavelength and the violet has got smaller wavelength here. Now, so if the wavelength is more, then it will have more velocity. The velocity of red will be more than the velocity of the violet here. Okay. So the one which has got more velocity will bend least or less. So red will it will deviate, or in fact it will bend less as compared to the other one here. So let's see how do they bend here. So if you draw it, it will be something like this. Is a red, it will bend less. It's not visible, so let's make it red here. Fine. The other one will bend more. Why? Because it is it has got less speed, right? So violet has got less speed, it will bend more in this case. And when they bend more, then okay, it should be visible to you. So let's say make it word. Okay. No, I need to make it here. Fine. You can see it bend more here. Then the question they're asking you, have to draw it. Do you know how to draw that now? Then the question they're asking you, complete the diagram. We have done that. How do the speed of the ray differ in the classes? Simple. I mentioned that the velocity of red is more as compared to the velocity of violet in that class. Are the two refracted rays in the glass parallel? Refracted rays are these are the refracted rays. Are they parallel? You can see yourself. They are not parallel. Why? Because they are bending differently in it. You know the reason why is it so? How does the refractive index of a glass differ from the two rays? How does the refractive index of glass differ for the two rays? See, the refractive index of the first one with the red will be less and the refractive index of violet will be more. So see, refractive index is basically, it depends upon what of this glass. It depends upon velocity of light and velocity of light in space or vacuum and velocity of light in that medium, right? So if this is red for red, another one is mu glass, in this case say 1 and this is 2 here. This will be same glass, right? So I can't take it two glasses different here, right? So it is C and V here. Now which velocity is more? You can see this velocity is more, this is less. If the numerators are equal and denominators are different, the one having a smaller denominator will have bigger value. Say if it is 100 and 100, for example, this is 20 and this is 25. So it does it not give you 100 upon 20 as 5 and this gives you 4? So which is more? the refractive index which is more, this is more, so the other one is more. Okay, I made a mistake here. It was, this has to be higher velocity, right? So I wrote it wrong. I took it here as, say if this is 25, this is 20, then what will happen? Red has a more velocity and violet has a less velocity. So 100 upon 25 is 4 and this is 5. So which has got more refractive index according to this particular calculation? This will have. So when the numerators are same and the denominators are different, the fraction having the smaller denominator will have a bigger value. So in that case we can say there is a refractive index here for red will be less than the refractive index for the violet here. Okay, and both are for glass only. I'm just striking a red color, this is violet color here. Understood? So this is the answer for the last question here. I hope you have understood everything in it.